Britain once built an aircraft carrier out of ice. Not as a joke, not as a test. Winston Churchill personally approved it, ordered a full-scale prototype, and promised more if it worked. This is the story of Project Habbakuk, the most insane weapon of World War II that almost actually happened.
In 1942, the Allied forces faced a crisis. Supply convoys crossing the ocean were being hunted and sunk by German U-boats at an alarming rate. The core of the problem was the mid-Atlantic Gap, a geographic blind spot completely outside the flight radius of Allied aircraft. The only countermeasure was parking an aircraft carrier right in the middle of that gap, bridging the radii to hunt submarines from above. But standard naval architecture demands heavy resources. A typical combat-ready aircraft carrier requires tens of thousands of tons of steel. By this point in the war, the Allies had nearly exhausted their steel and aluminum reserves trying to keep up with standard weapons manufacturing. Commanders were trapped in a deadly paradox. Surviving the Atlantic required a colossal naval megastructure, but they possessed zero raw metal to build it. This bottleneck landed on the desk of Geoffrey Pyke, an eccentric scientific advisor to the British Combined Operations Headquarters. Pyke's mandate was to find a building material that was infinitely abundant, incredibly cheap, and required almost no metal. Pyke returned with a proposal that bordered on the absurd. He wanted to build an aircraft carrier out of floating ice. His reasoning came down to strict energy math. Manufacturing ice requires just 1% of the energy needed to produce an equivalent mass of steel. Under normal circumstances, an ice ship would be dismissed as a joke, but the slaughter in the Atlantic was so severe that Naval Command had to abandon conventional design and entertain the impossible. Pure ice is a terrible material for a warship. It is highly brittle, shatters easily upon impact, and melts rapidly in ocean water. To solve this, Pyke developed a composite material consisting of 14% wood pulp, essentially sawdust, and 86% water. They called it Pykrete. On the left is pure ice's fragile crystalline structure. On the right, Pykrete's interwoven fibrous matrix acts like steel rebar. When struck by a projectile, pure ice shatters, but Pykrete's matrix absorbs the kinetic energy. These fibers also block heat transfer, slowing melting. As a bonus, this new composite could be cut and machined just like ordinary wood, yet poured and cast into massive molds just like metal. By combining water and sawdust, Pyke engineered a bulletproof composite that bypassed the weaknesses of pure ice and pushed the physical boundaries of frozen water. This scale comparison shows the proposed vessel, Habbakuk 2, against a standard carrier. It was a behemoth nearly 2,000 feet long. Its primary defense was sheer mass, a solid Pykrete hull 40 feet thick, designed to absorb direct torpedo strikes without sinking. But this scale introduced a massive engineering contradiction. Standard ship engines generate intense heat, which would slowly melt the ice hull from the inside out. The workaround was to mount 26 electric motors in external nacelles along the outside of the ship, while weaving an intricate network of refrigeration pipes throughout the hull to keep the Pykrete permanently frozen. To prove the math worked, the Allies secretly constructed a 1,000-ton prototype in the freezing waters of Patricia Lake in Alberta, Canada. The Canadian prototype floated and held its structural integrity. The Allies now possessed a working model of the largest, most indestructible warship ever conceived. If the bulletproof Pykrete prototype worked flawlessly on the lake, why did the military intentionally abandon the project? The first fatal flaw was scale. Manufacturing 2.2 million tons of Pykrete required a staggering volume of wood pulp. Sourcing that much sawdust would have completely crippled the Allied paper and timber industries. Second, powering the massive refrigeration network required thousands of miles of steel tubing, cork insulation, and the installation of entire onboard power stations just to keep the coolant pumping. In their attempt to bypass the global steel shortage, engineers accidentally generated an entirely new, equally impossible set of logistical demands. Ultimately, Project Habbakuk wasn't defeated by the laws of physics. It was defeated by the rapid advancement of conventional military technology. By late 1943, the Allies introduced new, longer-range aircraft like the B-24 Liberator, which carried enough fuel to patrol the dead center of the ocean. Combined with the mass production of smaller, cheaper escort carriers, these bombers closed the mid-Atlantic gap, completely eliminating the tactical need for an unsinkable ice island. The Berg ship was outpaced by time. But the fact that a functioning prototype was built, one so durable it took 3 hot Canadian summers to finally melt, proves that absolute constraints can push human engineering into brilliant, entirely unexpected directions.